Hello student, welcome to our physics discussion, that is physics in a smart way. Today we shall pick up a different topic just like our last calculus, and that is highly essential in the study of our natural science, especially physics. That is nothing but coordinate geometry. Coordinate geometry. Sometimes people say coordinate geometry. Some people say that is geometry of R square. Sometimes people say that is planar geometry. It's all okay. But the most popular name is coordinate geometry. So perhaps coordinate geometry is there. The topic starts with equation of a line. Equation of a line. But as you very well know, so perhaps if you compare different type of lines, straight line is easiest. So equation of a straight line. Equation of a straight line. Okay. But first of all, let us try to understand what do you mean by the term that is equation here. Equation of a straight line, or basically equation of line. I'm not confining myself to straight line at present. For 2 or 3 minutes that we're talking of the issue. So what do you mean by the equation of a line? By the term equation, let us go for a line. I have drawn the x and y coordinates, and I have drawn a straight line. Here you may draw a straight line or a curve, doesn't matter. You know, a line, it consists of several points. Several points. If the line is straight, you take 2 or 3 points. They may be closely spaced, they may be a bit far apart, doesn't matter. You join them by a scale, and then straight line comes up. If it's a curve, you take several points which are close by, because the curve has to be drawn. A hand-driven curve, a handwritten curve has to be drawn by freehand, and then you take several close by points for that. You take several close by points and draw it by freehand. Then the curve comes up. But when you mean by equation, what do you mean by equation? Let us consider a particular point which is on the straight line. The point has got its own x and y coordinates. Okay, x coordinate, y coordinate, you do understand very easily. This is coordinate geometry, and the point is on the line that we are describing, that we have picked up. The question is, this point is on the line, whereas another point we may mark here that is not on this line. Second point, maybe P dash, must be having its own x and own y. Okay, so now the issue is why this point P is on the line, but why this point P dash that didn't remain on the line, or that doesn't come up to the line, or that is not on the line, to be very straight. The answer is this point which is on the line has got its x and y. There is a relationship, special relationship between its x and y coordinate. And because that relationship is there, the point is eligible to sit on the line. Whereas the second point, which is off, OFF, of that line, it will be having its own x and y. But the relationship between its x and y is not the same as the relationship between this point P's x and y. So due to that factor, the point P remains on the line, whereas the point P dash is not. By that, we mean the equation of a straight line or equation of a line basically. Let us remove the word straight at present. Okay, so that means when somebody talks of the equation, we simply consider the special relationship between the x coordinate and y coordinate of the point, and with the help of on the strength of that relationship, the point is eligible to sit on the line, or the point is eligible to be on the line. I think my point is clear. Okay, so let us consider different type of lines, and let us consider. Okay, so we clear the screen and go into the topic. The first issue that we should discuss is the equation of a straight line that is passing through the origin. As an example, I have drawn the straight line. And that is passing the origin. In fact, that is not the only one line that you can make it to pass the origin. Many different lines you can draw, and they remain in all the possible coordinates, first, second, third, and fourth. Okay. So they remain in all the possible, they remain in all the quadrants, a straight line. Okay. So as an example, we cannot take all the lines, but we have to have a formula or a relationship, or to have a theory which will be encompassing, or which will be trying to help us in finding out or solving all the line cases which come under this category, straight lines passing through origin. But first of all, one issue needs to be clear. We know that is positive x-axis, and that is the line of ours which I have marked in red. Starting from positive x-axis, you turn towards the line. You know, in trigonometry, school level trigonometry, that is the way we measure the angles. You start to count the angle, you start to turn starting from positive x-axis. That convention is still valid. If this angle is theta, then this theta is known as slope angle. And tan of this angle is written by a very small letter m, and that is known as slope of the line. You have to keep this permanently in the mind. Whenever you draw a straight line, doesn't matter whether the straight line remains in first or third quadrant, or second and fourth quadrant, doesn't matter how much angle you have to cover, whether it is acute angle or obtuse angle, but always your start must be from positive x-axis, mind it, not negative x-axis or any y-axis, z-axis, and turn towards the line. The angle that you cover when you reach the line, by the time you reach the line, that is known as slope angle, and tan of that angle is known as the slope of the line. That is written by a letter, a single letter, that is m. Every time writing tan theta can be tedious. So thereby tan theta is replaced by a single word slope. You may be wondering why I have taken, or you have taken, tan theta. Why not sin theta, cos theta, sec theta, cosec theta? There are so many thetas, or so many trigonometric functions available. You will be coming to know shortly. Don't worry on that. We know our basic job is to find the equation of a straight line. So if you consider a particular point on the line, the point must be having its x and y coordinate. And if somebody asks you to present those coordinates so that we can visualize them with this is x and that is y, as everybody knows, at least we all do know. Okay, That is the straight line. And the moment you mark off X and Y and the line, we clearly see a right angle triangle. But our basic job is to go for the equation. Equation means the special relationship which exists between the coordinates of the point or points which are occupying or which find a place on the line. And finding that is almost easy or very easy. If I consider trigonometry, and if you take tan theta, tan of this angle, we know slope is known as tan theta, okay? And tan theta, from our school level, we know that is perpendicular by base of the right angle triangle. We know perpendicular is y and base is nothing but x. So we consider this m equal to y by x, and we cross multiply it. And when you cross multiply it, we find nothing but a very simple relationship, y equal to mx. And that is nothing but the equation of the line. And mind it, if you change the value of m, because m equal tan theta, for different value of theta, you'll be getting different value of m. So thereby, taking the different value of m, we can find many different lines or straight lines which are passing through origin. Maybe y equal to 2x, or maybe y equal to x by 5, where m equal to 1 by 5, or maybe y equal to 20x, or maybe y equal to 30x, something like that. So many different straight lines are there. Okay. And if the line is remaining in the first and third quadrant, then its slope is positive. If the line remains in the second and fourth quadrant, you know the slope angle will be an obtuse angle. There we'll be having equation like y equal to minus say 4x, or y equal to say minus x by 10 or something like that. So the moment you see the m has become negative, that means the line, it is to remain in, or it is to be drawn in the second and fourth pattern. I think that is clear. Okay, so we go to the second point of our discussion, but before that, let me clear the screen. Okay. Okay. Okay, we come back to the second point, or the point number 2. Point number 1, we have discussed the straight line passing to origin, but you might be wondering, do all the straight line need to pass through origin? Answer is right way no. So here we consider those straight lines which seemingly do not pass through the origin. Okay, so equation of straight line, we have taken straight line not passing through origin, not passing through the origin. Equation of straight line not passing through the origin. But when you consider these lines which are not passing through the origin, there are millions and billions of lines. Equation can be defined, can be found out. Equation can be developed in many different styles, and you have to know all those possible styles, especially those styles which are relevant or useful in our solution of the problems in physics or in understanding the physics. So the first one that comes in, the equation of a straight line not passing the origin, that is the common header for all those things, bit A in Y-intercept form. In Y-intercept form, you might have seen some police vehicles which are branded as interceptors, and they are cunningly deployed near national highway and all that, but they will be somehow hidden from your view as you speed down the highway. Okay, if you exceed the speed limit, they try to run after you and possibly intercept you. Then they can give you a challan or some sort of fine that uh, that you are exceeding the speed limit. You have to pay the fine. Those vehicles are known as interceptors. Those vehicles are known as interceptors. Okay, so intercept means to cut down something, cut off something. So here we got the equation of straight line in Y-intercept form. Our straight line is shown in red that cuts the y-axis at this point, and from origin you count the distance where the straight line cuts the y-axis. That distance is usually taken as C. Why I have taken at C, not A, not B, or like that? There is no logic to that. Our mathematics books, they take it as C. So if you take C, that will be convenient. That will be convenient. Similarly, if the straight line cuts x-axis, from the origin, you take the position where the cuts x-axis, that intercept is x-intercept. It's x-intercept, and here in the C is y-intercept. Okay, so thereby you know now the meaning of intercept. So from the origin, you take the point where the line cuts the y-axis and the distance is C. So C is y-intercept. Y-intercept. Okay. And our equation will be containing C because our heading is in Y-intercept form. That's a very, very popular form of the equation. So if you consider, so now you know the Y-intercept. If you consider the slope angle here, we know the line cuts the y-axis near the origin at a position like this. If you try to find the slope angle, you know you have to drag the line backwards like this and go for a very big picture. Without doing that, we may draw an auxiliary x-axis or positive x-axis here, okay, and try to find the angle starting from x-axis to the line, that is slope angle. Because if this is x-axis, it's because this is x-axis, okay? Or this line is a representative of this line for these positions. So that is the slope angle. We take a point as usual, the point on the line, the point is having coordinate x and y. And if I draw the x and y coordinate, if I show them, we know this is x coordinate. If this is x, that distance also is x. We know this is C, so that distance is C, but the whole distance is the y coordinate. This is y, the vertical distance. And from the ground level or from the x-axis, that is C. So this length must be our y minus C. As you can clearly see, simple geometry. If I consider tan of this angle, we know that is again a slope angle, and tan of this angle will be slope. So thereby, we know tan theta will be equal to slope, and that will be perpendicular by base. You know perpendicular is y minus C, by base is x. If you take these and cross multiply, we know y minus C, that comes out as mx. The last step will be our equation. If you try to send C to other side, so y equal to, or y becomes mx plus C. That is the equation we are searching for, or equation in y-intercept form. Okay, y equal to mx plus C. But don't think that it will be always having plus C, because I can show you some practical equations, y equal to 2x plus 3. Okay, sometimes equation can come out y equal to, let us say, 3x minus 5. So when you see this equation, you may not be worried. Here, in place of c, we got minus 5. Minus 5 means y-intercept is negative. The line is cutting the x-axis below the origin at a distance 5 below. Okay, so y-intercept can be positive, y-intercept can be negative, doesn't matter. So basically the general form is y equal to mx plus minus c. Anyway, that's all for today. Thank you for your viewership. If you find it useful, you can give it a like, you can share, or you can share, you can subscribe, and can share it amongst your friends. Thank you again.